So here we have this question. In this question they are asking us to find the correct graph corresponding to the electric field due to a spherical cell. So electric field due to a spherical cell, if I draw a spherical cell here, okay, that is uniformly charged and that has a surface charge density, let's say that is sigma, and having total charge Q. Now this is the center here. So if I consider Gaussian surface, let's say if I consider Gaussian surface here, so in this Gaussian surface, if I ask you what is the charge enclosed by this Gaussian surface, you will say that Q enclosed is how much here? Q enclosed, I will say that is equals to 0. So when Q enclosed is 0, if I write integral of E dot ds, then according to Gauss theorem, that is Q enclosed by epsilon naught. So here by symmetry, you can say that this one, this element that I have taken, it has a symmetry about the center. Okay, so by symmetry I can say electric field will be same everywhere on this point. So I can take this E out and integration of, let's say that is ds surface, and Q enclosed, that is 0 by epsilon naught. So this is basically 0 here. So it gives us that E and surface integral is non-zero here, because this Gaussian surface has certain amount of area. So this is non-zero and the product of these two is 0. That means E has to be 0 here. Okay, so electric field for I can say for R less than R, okay, electric field is 0 here. Okay, now if we talk about for outside point, okay, for outside point, if you see for outside point, so for outside point, suppose this is the sphere that we have here, okay, spherical cell, and if we draw the Gaussian surface on it, let's say this is the Gaussian surface I have drawn here. So this is the sphere and this is another sphere. So this has a charge Q on it, and for the outside point, if you see, so here if you write E dot ds, okay, that should be equals to Q enclosed by epsilon naught. Now because it encloses the total charge of Q here by epsilon naught, and then electric field will be same here because it has a central symmetry and charge distribution is also symmetrical. So electric field will be same everywhere on the surface of this Gaussian surface. So I can take E out and integration of ds surface area will become 4 pi r square. Okay, so this radius is r. So in that scenario, we are going to get E equals to Q divided by 4 pi r square epsilon naught. So you can see that for r greater than r equals to r, E is inversely proportional to 1 by r square, and for r lesser than r, E is equals to 0. So the correct option should be option 1 here.